Good evening, everyone. My name is Mansi Tripathi. I am TA for this course, Environmental Chemistry. So today is the week 5 of the course. So we'll start with some introduction. Then we'll see some question answers that are related to assignment as well as that are related to the examinations. Further, we'll move on with the doubt in case if you have any. Then, without any further ado, we'll start the session. I'll share my screen. Then we'll see the questions and introduction and everything. I hope this is visible. I'll check that as well. Okay. So I'll change my pointer. So welcome to Environmental Chemistry, week 5 of the problem solving session. So what are the things that has been taught in this week? So first was the acid base reactions. So here we learnt about the basic concepts of acid-base reactions. What is acid? What is base? All those things have been previously taught, but this first session was a bit revision of everything. Then we studied the carbonate system. First we studied the closed system. Then we studied the open system. We also studied about the log C and pH values graph. So what was that? This is just a basic graph between log C and pH. So this is our H, this is OH. So that was the first lesson in this week. And depending upon the other composition, if we talk about acetate, this is HA, and this is our AC. This is not up to scale. Okay, so we studied about log C versus pH values. So there were various parameters by which we have derived the equations for all these values. Like for example, if we talk about this graph, I'll use some other pointer. If we talk about this one, the equation was log H is equal to minus pH. Similarly, we derived equations for OH. Also, we derived equation when pH is less than pKa or when pH is greater than pKa. So these were the situations for which we have derived equations. From that we have created this graph. After that we studied about carbonate system, which was closed system. So what was happening in the closed system? Normally what happens? If this is our atmosphere and water interaction, water is filled here. So what happens? If it is closed system, this whole system will be filled with water. There is no interaction from the outside world. So there is no interaction from the outside world. So what happens? There is no escape of carbonic acid or influx of carbonic acid. But what happens in open system? Open system, interaction between the atmosphere and the aquatic system is allowed. So either the carbon dioxide can come in or the carbon dioxide can go out depending upon the concentration. So this is open system. Open system is bit more complex than the closed system. Okay. Then here in closed system there were few equations which were used, and we came to know for closed system the important parameters are H total. Okay. Then it was pH. So these two parameters are common for both the systems. But here another parameter was CO3 total. However, for open system, what were the parameters? HT, pH, and CO2. Okay. So these were the parameters for the open system. Then we have solved few questions using visual Mintek and all. Okay. So what is the difference between open system and closed system is? In closed system, total species will never change. Total species inside the water will never change. Either it can be H plus or it can be carbonate or anything. It will never change. However, in open system, the quantity of the species may change in the aquatic system because there can be influx or efflux of carbon which is in equilibrium with carbonic acid, carbon dioxide. Okay, this is there. It can lead to the formation of H2CO3 on interaction with water. Okay, so due to this, but the total H, which is the sum of H in air, H total gas, and H total liquid. Their sum is constant before equilibrium and after equilibrium. So this was where the concept of open system was based. Further, we studied about titrations, acid-base titration. Titrations are used for many other applications like alkalinity, acidity, but we studied about acid-base titrations. We studied about equivalence point of as well. Okay. So what is equivalence point? Amount of acid is equivalent to the amount of base. The point at the point at a particular pH, when the amount of acid is equal to amount of base in a system, in a controlled system. Okay. So we also solved a few questions on this in Visual Mintek. After that, we studied about buffers. So we used multi-problem or sweep to solve this titration questions using computer solution, that is Visual Mintek. And we had a brief introduction of buffers. Not everything. Next week it will be properly covered. But here just a brief interaction was there. So we'll see some question answers. Then we'll start the doubt solve session. So the first question is, in the log C versus pH diagram given below, values 0.1 to 5 are given. Which one of them denote the point where pH is equal to pK for monoprotic acid system? We're talking about monoprotic acid system, and you can see what is representing what. This one is H plus, this one is OH minus, this one is HAC, and this one is AC, acetate ion. So among these points, which one is representing the equivalence point? The point where pH is equal to pKa. Please take your time and find out the solution. You can write the solution in the chat box as well. After a few seconds, you can take a minute for doing so. Then we will see the solution. We'll see the solution now. So the solution is C. Option C. This one. This is our solution. So where will the pH is equal to pKa? This, in acetic acid system. This is pKa. Here the conjugate acid is equal to conjugate base. The concentration of conjugate acid is equal to conjugate base. This is the point 3. Okay. At pH is equal to pKa, HAC, activity of HAC is equal to activity of acetate, which is at point 3. Coming to next question. Which of the conditions given below are true for log C versus pH diagram given in question number 1? Take a minute or two. Please solve this question. This has been properly derived in the class. Please have a look and let me know the correct solution in the chat box. We'll see the solution now. So the option B, C and E are correct. When pH is equal to pKa, log AC minus is equal to log pH plus log Ka plus log AT. That is A total. When pH is equal to pKa, that this we have seen in the previous problem as well, log HA is equal to log A negative. When pH is greater than pKa, log HA is equal to log AT minus log Ka minus pH. Okay, so this is the solution. Please go through it once again, and in case of any doubt, you can ask me. Please have a look, note it down properly so that we can move forward. We'll move forward to next question. While preparing the log C versus pH diagram for a solution at the equilibrium with ammonium ion concentration of 10 raised to power minus 4, having pK 9.24, the correct linear equation for NH3 when pH is less than pKa is. Please solve this question. This is very simple. You can use diagram to solve this, or you can just relate it to the one we have solved in the class. We'll see the solution now. So the solution is PHNH3 is equal to 13.24 minus pH. How did we guess this equation? PNH ammonium ion is equal to, this yields to NH3 plus H plus, and what will be NH3 total? This we got from the tableau and all, okay? So NH4 ammonium ion plus ammonia is equal to 10 raised to the power minus 4 molar. This is given. What is alpha 1? Alpha 1 is NH3 divided by ammonium total, like this. And NH3 how we can get? By simplifying it in terms of KaNH plus. So NH3 is equal to this thing. Now, when pH is equal to pKa, we have H plus so much greater than Ka. Okay. Then just by this H plus is so much greater than Ka, then this Ka can be ignored. So NH3 is equal to Ka upon H plus into NH3 total. Now just doing log both the sides. Log NH3 is equal to log Ka minus log H plus log NH3 total. How log NH3 can be written? Minus P NH4. This is pKa. This can be written as pH, and log NH3 total, it's given 10 raised to power minus 4. So this is how much? 10 raised to power minus 4. When we'll put log here, we will get this minus 4. So PaNH3 negative is equal to minus 9.24 plus pH minus 4. Then NH3 is equal to 13.24 minus pH. Please go through the solution once again. Let me know in case of any doubt. Then we'll see the next question. Moving forward, question number 4 is a 500 ml water sample is collected, out of which 200 ml is titrated with 0.03 normal sulfuric acid. It is strong acid. We have solved the problem of strong acid only to the end point of 4.5. This is equivalence point. Titration consumes 50 ml of sulfuric acid. The total alkalinity HCaCO3 is, okay, these are the options. Please try to find out the answer of this question. Here the important point is this is H2SO4, so it will give 2 units of or 2 moles of hydrogen. Okay. Also, we need to convert the alkalinity in terms of CaCO3. So please keep that thing in mind and solve the question. equivalent weight will be considered here. We'll see the solution now. The solution is 375 milligram per liter. Please match it with your solution. So this is our solution. Normality. Equivalence point problem are solved using normality, not molarity. That's why I asked you to consider that H2SO4 is giving 2H plus. Okay. Normality is equal to weight in grams divided by volumes in liter multiplied by equivalent weight, which is equal to gram equivalent weight divided by volumes in liter. So normality equation is this: N1V1 is equal to N2V2. So acid and water sample, N1V1 is for acid and N2V2 is for water sample. So N1 is 0.03 normal into 50 ml. We need to find N2 for the acid that has water sample alkalinity that has been given into 200. So from here we got normality is 0.0075 normal. Now we need to find out everything in CaCO3 terms. So weight in grams divided by volumes in liter is equal to normality into equivalent weight. Equivalent weight of CaCO3 is 50. How does this come in? When we write CaCO3 dissociation equation, CaCO3, it gives Ca 2 plus, then here we are seeing that valency is 12. The molar masses or molecular weight is 40 plus 12 for carbon plus 16 for oxygen into 3 because 3 oxygen molar, atoms, which is giving us 100. And here we are saying valency is 2, right? So equivalent weight is 100 divided by 2. Molecular weight divided by valency. So we got 50. So from there this 50 is coming. We just total alkalinity of CaCO3 is normality into 50, that is equivalent weight. So we got 0.375 grams per liter, which is equal to 375 milligrams per liter. Have a look to this. Have a look the solution. Then we'll see the next question. Please note it down. We'll see next question. Consider a closed system prepared with initial concentration of Na3PO4 as 1 molar and Na2HPO4 as 2 molar. H2PO4 as 3 molar and H3PO4 as 4 molar. The correct equation for total HT or total H is equal to, among these, what is the correct equation? Please solve this question. We'll see the solution in a while. We'll see the solution now. Please have a look at the solution, then I'll explain. Please note it down, it will be easier to explain. So the solution is the HT is equal to H plus minus OH, which can be written as Kw by H plus 3 alpha naught 2 alpha 1 plus alpha 2 PO4 T. And H2 is also is equal to Na2HPO4 naught plus 2 NaH2PO4 naught. This is the recipe species 3H3PO4 naught, where C naught shows the initial concentration of C, means the recipe. So looking at these, what are the species that we have got? These are sodium ion, hydrogen ion, hydroxide ion, phosphate ion, HPO4 2 negative, H2PO4 negative, H3PO4 in aqueous solution. So what are the components that are required to prepare these species? This Na plus, H plus and PO4 3. So these are the formation equations. For making out Na plus we need 1 Na, for H plus we need H plus. For OH, we need H2 minus H plus. This is in bulk, so only minus H plus will be used in the W. For making PO43 negative, we need 1 PO43 negative. HPO42 negative, we need H plus HPO43 negative. For H2PO4, similar equation, but one more H. And for H3PO4 negative, similar equation with one more H. Okay, so 3H plus HPO4 3 negative. Note it down so that we can move forward to the next part of the question. We'll move forward. So this is the tableau. These are the species and these are our components. From there, we can prepare this tableau and write the equation for HT. Okay, so these are our equations. Please have a look at this, then we can move forward. These four are our recipe species. Moving forward, alpha naught is H3PO4 divided by total phosphate. Alpha 1 is H2PO4 divided by total phosphate. This is alpha 2 is HPO4 divided by total phosphate, and alpha 3 is PO4 divided by total phosphate. Why these many alphas? Because this is triprotic acid. Three protons are available. That's why. So Kw is H plus H plus multiplied by activity of H plus divided by multiplied by activity of OH. So this, when we will put this in this equation, this earlier equation, this one, the last one, then we will get this. Have a look, then we'll move forward. we'll see next question. Question number 6 is, consider a closed system prepared with initial concentration of Na3PO4 1 molar, Na2HPO4 2 molar, NaH2PO4 3 molar, and H3PO4 of 4 molar. Then the correct equation is, please try to find out the solution of this question. This is similar to the previous one. We'll see the solution now. So the answer is A and D. Total Na is 10 molar and total H is 20 molar. Please match it with your questions, with your solution. Then we'll see the how we got this solution. You see the solution now. So from question number 5, we got this HT, which is equal to NaHPO4 to NaH2PO4 and 3 times of H3PO4 concentration. Then we have the values 1 into 2 plus 2 into 3 plus 3 into 4 is equal to 20 molar. Similarly, for Na also, 3 Na3PO4, 2 times Na2HPO4 and NaH2PO4 recipe. Then we got 3 into 1 plus 2 into 2 plus 1 into 3, which is 10 molar. So that is how we got this. Please note it down so that we can move forward to next question. Next question is for H3PO4, pKa1 is 2.15, pKa2 is 7.20, and pKa3 is 12.35. Then the correct order of predominance of species, these are the species H3PO4, H2PO4 minus, HPO4 2 negative, HPO4 3 negative, respectively, for the pH of 2, 5, 8, 11, and 13 is. These are the pHs. Now, these questions can be solved by drawing log C versus pH diagram. Please try to solve this question, then we'll see the solution in a while. We'll see the solution now. So this is the alpha versus pH diagram. So see, this is how we got how this H3PO4 is coming down at certain pKa1. At pKa1, H3PO4 is equal to H2PO4. At pKa2, H2PO4 is equal to HPO4 2 negative, and here HPO4 is equal to PO4 3 negative. These are different pKa value. So please have a look at that. Then we'll see the solution is right over here. Please note it down, take a screenshot as well. Then you can understand what is happening here. We'll see next question. A solution prepared with initial concentration of NaHCO3 1 millimolar, Na2CO3 is 2 millimolar are put in closed system and the system is allowed to equilibrate. pH is X. Now, if the system is open and allowed to equilibrate with the atmosphere having partial pressure of CO2 is 3.8 into 10 raised to power minus 3 atm, then the difference between the pH will be okay. So here two parts are there. First, you need to solve it as closed system, then as open system. Visual Mintek can be used to solve the problem. There are no options. You can directly give the answer. Please try to solve this question. Take your time. So the solution is 2.44. NaHCO3 is 1 millimolar and Na2CO3 is 2 millimolar. So Na total is, from where Na is coming, NaHCO3 and 2 times Na2CO3, because we have 2 here, so multiplied by 2. And here 1, because here 1 is there. So we got 5 millimolar. And what is H plus? H plus is coming from NaHCO3 and nothing is coming from Na2CO3. So we got 1 millimolar. And CO3, how it is coming? NaHCO3, Na2CO3. So we got 3 millimolar. So we will use visual minter. This is closed system. We will put Na value as 5 millimolar, HT as 1 millimolar, CO3 is 2 millimolar in add components. Okay, very simply we will do all these things. Then this thing is added. Please do till here. Then we will see forward. We'll move forward. So we will click on run after putting all these things. Then we will get this solution. And the pH what we got is 10.34. So this is pH for the closed system. Please match if this is coming in your visual minter. Ionic strength is also given. Okay, there is some change between concentration and activity because ionic strength is kind of high. We'll move forward now. Now, after doing all that thing which we have done for the closed system, now it is the time for the open system. So here we will click on the gases menu and then specify partial pressure. By default is either 4 into 10 raised to power minus 3 or 3.8 into 10 raised to power minus 3 default. But if you are using Visual Mintech 4, it will be 0.0004 atm. Okay, or so you need to convert it to make it to 3.8 into 10 raised to power minus 3 because that is being given in the question. So put the partial pressure as 10 into 0.00000838 and click add. Okay, because it is given as 3 into 10 raised to power minus 3. Then click add. Do this thing, then we'll move forward. We'll move forward. Now we will run Visual Mintech and we got this pH, thus ionic strength. So ionic strength is C. You can see that there is a lot of difference between the concentration and activity. So this is because of the high ionic strength. Now pH what we got is 7.9. The difference between the pH is 10.34 minus 7.9, which is 2.44. Question number 9 is, this is question number 8. If the system is, okay, if the system is kept open in a room in which the partial pressure is 3.8 into 10 raised to power A, where A is an integer and the pH of the solution is 4.9, then the value of A is, okay, try to find out the answer of this question. This is kind of reverse pH question. that we have seen earlier as well. Please try to find out the answer of this question. We'll move forward then. So the answer is 0. We will see how. First, we will specify the gases at equilibrium, which is 0.0038 atm. Now, first interaction, it will be 1. Partial pressure is 3.8 to 10 raised to power minus 4 atm. Thus, in the option say, enter the partial pressures. Pressure is a multiple of option X. We can put different values so that we can get pH 4.9. So, this is like trial and error as we have seen earlier. So, after putting different trial and error, we will get the solution. Though we will choose that number here, X, which will give us the solution as pH 4.9. So please have a look at this. Then we'll see the next question. We'll see. So if A is equal to 0, these are different iterations. If A is equal to 0, then we got, okay, pH 4.9. So when A is equal to 1, then 3.916. When A is equal to -1, we got pH as 5.9. A is equal to -2, we got as 6.9. And when A is equal to, so these are the different options that has been given in the multiple choice question we tried. Then the correct option is A is equal to 0. So this was the last question. So thank you all. I'll wait for some time. Please let me know if in case you are having any doubt. Then we'll move forward. Then we'll close the session.